Welcome to this guide on performance optimization in Kotlin. In this video, we'll explore practical techniques for writing efficient Kotlin code that runs faster, uses less memory, and provides a better experience for your users. Performance optimization is crucial for building professional applications that can scale and compete in today's market. Before diving into optimization techniques, let's understand why performance matters. First, user experience. Fast applications retain users and keep them satisfied. Nobody wants to wait for slow, laggy apps. Second, battery life. Efficient code reduces energy consumption, which is especially important for mobile devices. Third, cost savings. Optimized code requires fewer server resources, reducing your infrastructure costs. And finally, scalability. When your code is efficient, it can handle more users without requiring expensive hardware upgrades. Let's start with collection operations. When you chain multiple operations like filter and map on a list, Kotlin creates intermediate collections for each step. This creates unnecessary objects and slows down your code. Instead, use sequences by calling a sequence before your operations. Sequences use lazy evaluation, meaning they process elements one by one without creating intermediate collections. This can dramatically improve performance, especially with large datasets. Just remember to call to list at the end if you need the final result as a list. Higher-order functions that accept lambdas are powerful in Kotlin, but they come with a performance cost. Each lambda creates an object allocation at runtime. To eliminate this overhead, use the inline modifier on your functions. When you mark a function as inline, the compiler copies the function's bytecode directly to the call site, avoiding the lambda object creation entirely. This is particularly useful for small, frequently called functions that accept lambda parameters. Object creation is expensive, and unnecessary allocations can severely impact performance. A common mistake is string concatenation in loops using the plus operator. Each concatenation creates a new string builder object, leading to hundreds or thousands of allocations. Instead, use buildString, which creates a single string builder and reuses it for all append operations. This simple change can make your code orders of magnitude faster when dealing with large amounts of text. Kotlin provides value classes, which are perfect for creating wrapper types without runtime overhead. By adding the @JVM inline annotation and using the value class keyword, you can create type-safe wrappers that exist only at compile time. At runtime, the wrapper disappears and only the underlying value remains. This gives you type safety without the memory cost of boxing. Combine this with data classes for efficient data holders that automatically generate equals, hash code, and copy methods. Not all properties need to be initialized immediately when an object is created. Expensive operations like database connections or network calls should be deferred until they're actually needed. Kotlin's lazy delegate makes this easy. By using val property by lazy, you ensure the initialization code runs only when the property is first accessed. The value is then cached for future use. This improves startup time and avoids wasting resources on objects that might never be used. Kotlin's null safety is great for preventing crashes, but redundant null checks can hurt performance. When you use the safe call operator multiple times on the same property, Kotlin checks for null each time. Instead, store the nullable value in a local variable and check it once. Kotlin's smart cast feature will then treat the variable as non-null within the if block, eliminating redundant checks. This makes your code both faster and more readable. For concurrent operations, Kotlin coroutines are incredibly efficient. Unlike traditional threads, coroutines are lightweight and can handle thousands of concurrent operations without overwhelming your system. Use Async to launch parallel operations and await to get their results. The coroutine scope ensures structured concurrency, automatically canceling child operations if the parent scope is canceled. This approach is far more efficient than creating multiple threads and uses significantly less memory. Let's recap the key techniques for writing performant Kotlin code. Use sequences for chained collection operations to avoid intermediate allocations. Minimize object allocations with value classes for wrapper types. Use inline functions to eliminate Lambda overhead. Defer expensive initialization with lazy delegates. Reduce redundant null checks by using smart casts, and leverage coroutines for efficient asynchronous operations. By applying these techniques, you'll write Kotlin code that's not only cleaner and more idiomatic, but also significantly faster and more efficient. Thank you for watching, and happy coding.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.